So what are the dikes? Many of you who are already working in a higher level know about this, and a lot of you might not know about the dikes, may have heard, because I see most of the people here are from geology, and a lot of time the geologists too, they think that the dikes are the geologic dikes. For example, we are not today working with the geologic dikes, but we are going to work on the water dikes. So what are the water dikes? They are basically uh, made of earth and sometimes occur naturally. And in the southern part of the country of Bangladesh, you can see a lot of these dikes that are built, and that are built for the purpose of preventing flooding or the surge inundation that occur during the storm surges. And also, some of the dikes work as an embankment to protect the river banks as well. And those dikes can also be found not only in the southern polders but also in the banks of our major rivers, where the river takes the meander or river takes a turn to change its path. So in this picture, as you can see, you guys can easily see a dike. Many of you who did not encounter a dike before, or may have encountered a dike but never actually, without knowing it, that it is actually dike. So you have thought that it is just a road. But let me tell you, these roads are working as the dikes in the southern polders. As you can see from the other roads that are found in a polder, these kind of roads have a larger elevation, and they are most of the time made of earthen materials. And what the function is, you can do in this picture, this house, you can see this house and this pond and that dike. On the other side of the dike is the river, and that connects to the ocean. So I have a similar picture of the same part, that after this dike was destroyed by a storm. So if I share it right now, as you can see, this is the same dike that I was showing you just a minute ago. And this is this is what happened to this dike after a storm has occurred. To get a more visualization, then I'm going to give you a aerial view. Now you can see that this was the entire dike, and this was the part of the sea, and this was the houses and all other agricultural lands within the polders. So this dike was built to prevent the flow, but it did prevent the flow to some extent, but it got damaged. And in our Mapathon training, our main focus will be to map these dikes, or the portions of dike that are damaged, or that are vulnerable, or that are very close to the river banks and have a very uh, possibility of getting damaged in near future. Now, moving on, these are the four major things, as you have already seen from our training videos. We are going to map. First, we are going to map the dikes. That will include two major kind of dikes: damaged or vulnerable, or the dikes that are in good condition. And also we are going to map the sluice gates, canals, and road network. All of you are know what the canals are and the road networks are. Let's just give a brief overview of the sluice gates. Okay, the sluice gates are mainly built over a dike, that is on the connecting point of a dike and a canal. So basically it functions as a gate there to surpass the water. Or for example, if there is a surge and there is a lot of water in the polder, and that water needs to be excluded or needs to be get out of the polder, then these dikes have this kind of, as you can see here, this sluice gates have this kind of gates that can be manually opened, so the water that is inside the polder can easily come out, making the polder less inundated. On the other hand, it can also work vice versa. When there is a high surge, the dike sluice gates are almost closed, so that the water cannot go inside from the within the sluice gate. So that's how a sluice gate works. To make a better idea, here you can see, so these are the manual part of the gates that can be opened manually. When there is for example, if there is water in this side, the gates can be opened, so the water just comes out from here and goes to the sea or the ocean or to the rivers. And on the other time, the sluice gates are almost closed. And moving on, let's start with some briefing of our training. First, in today's session, we are going to learn this kind of things. First, we will learn how to import satellite image of different sources using Python that is inbuilt in our QGIS environment. Then we'll learn how to determine the vulnerable dikes using images of different years, because if you just see one image you will never be able to see what that image used to look like before. So that is why we are going to have images of different times, and basically we are going to have image from three different years, that is 2012, 2015 and 2018, and based on those images we are going to make our analysis and make our mapping. After that, we are going. This is the main part of today's training, that we are going to learn how to calculate those changes, because you can just visualize those changes, but visualizing will not allow you to update those informations into the report that you have to submit later. So in the report you have to include some values. For example, the length of the dikes, the areas of the polders that have been gained during the last 5 years, or the length of the dikes that needs to be reconstructed. So we'll learn how you guys can calculate those values from the shapefiles or from the satellite images. After that, I'm going to give you some tips on some of the basic mistakes that a newbie does while using QGIS. And for example, you might face some technical difficulties, like you have trying to open a layer, but that layer is not showing, or maybe on the other hand, you have mismanaged two different projections. For example, the satellite image entered it in a different projection. On the other hand, the layers that you have prepared, they are on different projection. That is why they will not match to each other. That is one kind of concern. So we are going to address those kind of things. And lastly, I'm going to give you some basic tips how you can manage the colors, and how you can manage the save files, how you can manage the legends to make those maps visually in a better way, and so that the viewers who will see those maps can get a better idea, and also can get some good idea of what are the actual things you have done. And now, one important thing, as you know, that the all those materials, all the works done by you, all the shape files that you are going to prepare, we are having trying to upload those shape files in a global environment known as the OpenStreetMap platform. People from all across the world use this platform to use this data. So if we are able to upload your works into this server, it will be a great contribution from all of you to the scientific community across the world. So while making the shape files, or while making all the updating all the information, you guys have to be very careful and keep in mind that your work are going to be used for a better purpose, for scientific purposes. And the second thing is that the result of the group work will be offered to the Bangladesh Delta Plan Office. Our head of department, Femcase Kahasfoot, is will try to do that, so that this will also help our government in another way, so that this mapping training is actually pretty important to both of you and to us and to our governments. So thank you. And the last thing, and this is that, since you just I have mentioned that these assignments are so much important, just not consider it as an exercise or any kind of assignment, because it is your own contribution. So you really don't want people to use wrong information, right? That's why while you do the mapping, you need to be very careful to achieve the highest amount of accuracy that is possible. And the second thing, in the group project, as you see saw from our grouping list, that most of you are from different organizations, and each and every one of you have different kind of experiences. So while you are performing the group work, we will request you to be very much respectful to each other, and maintain a very good manner while working. So this is for now. Right now, after my mapping is finished, my partner or my partner trainer Frederick will show you how you are going to document all those things and how you are going to submit those group works and the presentations. For right now, I am just going to share my screen and start the mapping. Can I do it? Everyone is clear what I have just said?
Yes. I don't see any questions in the chat, but yes, go ahead.
Okay, if there is no question, then I will just start the mapping processes. Does it work for everyone? I think I can do it. Okay. Uh, Give me a minute. My QGIS is just starting. It is taking some time.
So to be clear, so you've like Asif, so there are different videos that you have already sent. This explains how you install QGIS, how to map the dikes, how to map the roads. So this YouTube videos actually are all already available. So this is also a good base. If you forget something, go back to the YouTube videos, and it tells quite a lot.
Yeah. So the purpose of the YouTube videos was not to make you a master of GIS, but to make everyone enable to contribute in this program, because a lot of people have already said that they are not familiar with QGIS, or someone may use other platform like ArcGIS, and some people may have never used GIS. So that is why those videos will just enable you to make your contribution into this program. And the group project is the final thing that will enable you to make a combined result, collecting all the information that you have worked on your assignments. And also, if I am not wrong, you guys have been provided with some special documents. Like I have also give you a short version of the Bangladesh Delta Plan 2100, and also the Coastal Embankment Improvement Plan. You can use those materials to get a better understanding of the economical and the ecological and the water kind of information on the water resources and the embankments, and then use them for your presentation or for your report. And also there is also already a lot of resources are available on the internet. You can just make your own efforts to collect your own documents and own videos, and then use those knowledge and use it for complementing your group work. I think that would be better for all of us. So now I think I should start the mapping, right? Okay, I'm going to make it pretty fast, since Frederick has already covered some of the topics in her presentation. So I'm going to just try to escape most of the things. Can you see my screen?
Not yet.
No, not yet,
no,
indeed.
Not yet. I can try another time. Now? Now? Can you see the QGIS window?
Yes.
Yes.
Okay, so you guys, I will start from the last portion that our sixth video was finished on. So I have prepared some things previously so that we don't have to cover much time. I'm just opening my project. Just wait for a little moment, it will take some time. Okay, I think you can get a better visualization from here. Can you see? Can you guys see? Is it visible?
Yes.
Okay, now.
Yes, Bhaiya, it is visible.
Okay, so in our last video, you guys saw that we have made some dikes, and some of the dikes were very vulnerable, and some of the dikes were pretty as you can see, pretty damaged. So in our report, we definitely have to include the values of those dikes, that how many kilometers of length of dikes are damaged or are vulnerable, and which portion of the boulder those dikes are situated. For example, if I take a Just give me a moment. Okay, dikes need reconstruction. Okay. Can you guys see a red color line? Right? Just make some response during the
Yes, we have.
training. Okay,
Yes.
Yes, we can.
so
Yes,
this
we are able
layer
to see.
contains the all the dikes that needs reconstruction in this particular folder. For example, we have this portion, and this portion that were needs reconstruction. And how did we identify that these are vulnerable? I have already covered it in my previous training video, but still I'm giving an overview here. For example, as you can see, I told you that most of the damaged dikes can be found in the bend or in the meander of a river. As you know, when a river mends or when a river tries to change its path, there is a meander in that portion, and the outer braided portion of that bend gets eroded, and that is why those portion contains the most dikes which are vulnerable. As you can see, this dike is right here. As you can see, right, this is a dike. And this image is from 2018. Now, if I just turn it off, you can see the difference, right? That in 2012 the dike was right in this position, okay, and in the right side there were a lot of areas of land, but at the same time in 2080s those land decreased because of those land were eroded. That makes this portion of the dike vulnerable comparing to this portion, because as you can see in this part of the dike it still have a lot of land in the right, so that will still take a lot of air to get eroded. On the other hand, this portion is already eroded, and that what makes it vulnerable when there is a surge or when there is a flood during heavy rainfall. And now in this way we are going to map all the vulnerable dikes. And to someone is turn on his microphone. Can you turn off the microphone? I cannot concentrate. Okay, so now in this portion we are going to learn how we are going to document the length of these dikes. To do so, I'm just going to turn off all other layers, and so I need the length of this portion. To get the length, just go to the attribute table by make a right click on the layer, go to its attribute table. And you can see there is no values right here, only the number or the IDs for the dike. The one ID represents the dike that needs reconstructed, and the 0 ID represent the dikes that are already well constructed. So I'm going to add a field first and then add some values of the length of this dike. Here you will find an option that is named as field calculator. If you click on it, you will find this algorithm box where you can run different algorithms. Since it is a line feature and we are going to calculate the length, first let's add a field just on the output field name, write length and make it a whole number and make it an integer. After that, on the search box, search length, and you can see there is a function, this hashtag length, and click it, double click it. This will add it to the algorithm box. And since the lengths are by default counted in meter in QGIS, and we want only kilometer information, so we are going to use a division and then divide it by 1000, so that this value automatically gets converted to kilometers. And then if you click OK, you can see another box here is added, and you can see that there is a box length and it shows all the dikes and its information on the how many kilometers. And if you make it an integer, it will only give you the accurate value. For example, if it is 1.5 kilometer, it will not show 1.5, it will show only 1, which is because due to you have selected the integer value. But you can change it. You can just again go to the length, and for now we want to add the added value. Again do it, and length, and I'm going to give it a full. and make it not a whole number but a integer 64-bit. Okay, and then run the same algorithm. Thus this will add a new field, and this time I think most of my dikes are 1 kilometer length, that's why the integer values are not counted here. But that's how you are going to have this entire information of the individual dikes. After you do it, you have two options to either you can add your calculator, use your calculator to count them one by one, or you can let QGIS. If there is a lot of dike, then you can use QGIS inbuilt statistics to find the total length which all of these dikes can combine. To do that, just go to the vector, and from here collect the analysis, and from there go to the basic statistics for fields, click on it, and for here we are going to calculate the statistics for the dikes. It is select this layer, and then on the ID select the ID of which you want to make the sum for. For example, we are going to get the length for the length and select it. Then just if you want to export it in a text file, you can just write it here and give it a file name and give it a suitable location that will be exported as a text file. Otherwise you can just run it. After you run it, on the log box you can see that the sum of the collection of the dikes is given here, and that's how you can just calculate the length. I think this part is clear to all of you. If it is, then you can make a response. Otherwise, I'll move to the second portion. Should I?
Yes,
I
it's
don't see any questions in the chat.
Okay.
I
Okay,
saw
now
who was talking before that? Before Frederic? Because maybe that you wanted to say something. Okay, no, you can. I think you can go ahead. But
Okay.
this was the previous part was so to calculate how many kilometers of dikes were vulnerable or not vulnerable.
Yeah. And then okay, let's do another thing. If you have, suppose you have only one dike and you want to just, that is vulnerable, and you want to calculate its length, if it is one or two dikes you can do it. But if it is a larger number of dikes, for example, you have 10 dikes and you have to calculate all of them and sum all of them, then you can use the algorithm function. Otherwise, there is a simple way. In the top, you can see there is a measurement tool. Just and make it to Cartesian, and then click either you need it on meters or kilometers, and if you just draw a line, it will give you the length. Okay, so you can also do it like that, and then you can note down the length. Okay, the total length can be, you can see the more I change, the more the length changes, and that can be done using manually. And I only suggest you to use this function when the number of your dikes are less. If it is a large number, then you can use the algorithm. Now moving on to the analysis for the areas. First of all, Frederick showed you in the last portion of her slides that the dikes, firstly the polders changes their areas because like I said, one part of the meandering of a river, in a meandering river, when there is a bend, the inner part gets or receives some extra length due to sedimentation in that portion. On the other hand, the outer part gets eroded. So from that portion, I can show that. Here is the image from 2012, and from here you can see this portion of the dike is right here. This light white portion, this is actually the land, and this portion is showing that a lot of sediment are just beneath the water. As you know, the close to the banks, the water depth is pretty low, and the satellite image can pretty easily receive the signals from there, and that's why it will show you the sediment below the fresh water. So this is not actually added to the polder yet, but there is a lot of sedimentation, and that indicates that this portion can gain some area in near future or later in future. And now if I turn off 2020 and just click on 2018, as you can see, just exactly what we expected, that this polder has will gain some land, and this polder will gain some extra area that will make a possible change to its boundary. And to make it more visually, I'm going to get it in a 2015 image, and here you can see that. Now we can see the difference, right? You can see here is the difference. So in those area, this area between these two lines, in 2012 there were only the sedimentation but no strong foundation of land in this portion. But in 2015, in 3 years, you can see this area is almost a strong founded land. And in 2018, not only it is the land, I can see there are some structures there, or some land farming or some land protection that are also provided in this part. So now, if suppose if you want to calculate that in a particular area how much length the polder actually gained, to do this, do one thing: just go to your vector layer, create a new go to the layer properties, create a new layer, and from there select a new shapefile layer. Just give it a name. I'm just giving it a name as demo, since it is a demo file. And then select it area, since we are going to calculate the difference in areas. Okay, and click OK. Now, in from our videos, you already know how to edit the files. Click on that link, click the toggle editing, and take a polygon. And for example, I am trying to understand that how much area this portion has gained. You will definitely take a larger area, but I am trying to just find the area of this portion, and I'll give it a value 1 and click OK. Now I'm going to calculate that this much of area has been extended in the last 5 years. And to get this area of this portion, you can go to the properties layer and then go to the open attribute table. From there, click the attribute edit box and give it a field area. Okay, and give it a whole number. You can give it 64-bit, or you can just keep it integer. In the search box, type area, and there are two areas. Don't click the one below, that will not done anything. Just click the one with the hashtag. And right now, since we are using a satellite image and the tiles are basically 30 by 30 and the resolution is in meter, so we want to calculate the area in square kilometers. That is why you have to divide it by 10,000. Okay, just give a division and make it 10,000. Okay, and if you click OK, the area of that portion will be added here. As you can see, that area has been added, that it is a 6 kilometers of length of area that the dike has got. And to make this one small thing, it is not possible for all of you to identify all the areas in different corners. It will be very much time consuming. To make it much easier and much less time consuming, you can do one thing. You can make a polder boundary correction from the satellite image of 2012 and then save it to a vector layer, and then turn off the 2012 and make another correction for the polder boundaries for the image of 2018, and then you can calculate both the areas for the 2012 polder area, and you can 2018 polder, and then you can just calculate the difference of those two values. That will give you all the areas that were gained or that were lost during the last 5 years in one single value. I think that would be much better. And now moving on, we are going to see some basic changes. Also, one more thing, in your presentation, Frederick showed you that you have to answer some question. We will provide you a document. There are some questions that you have to make an analysis and assumption that which portion of a dike people should make their community, or people should start living rather than living very close to the embankments. For that, I will provide you with a hotspot map for the population in those polders tonight in a zip file, and that hotspot map will look something like this. From here you can see that there is a color band. You can see the purple color. Is it clear? Can everyone see it? Please make some response, otherwise
Yes,
I'm not.
thanks, Asif.
Okay, so here the light purple color are showing that the hotspot in those folders. For example, if I go, as you can see, in this folder, this portion is the hotspot, and this is actually the junction of two folders. On the other hand, here, this is the hotspot. If I zoom it, why it is the hotspot? Now, if I turn this layer off, as you can see that there are a lot of communities are living there. It is almost a city that is built on this river bank. So now we are going to, we know the hotspot, and to make an analysis of that whether the communities are vulnerable or not, we are going to just see another image of a different year. So I can see in 2012, and let's see if there is any major change, right? I can see one change right here. You can see there is a bridge, and it is not still developed. It is maybe in the process of developing, but let's check it on 2018, and that bridge is completed, and that is why people are living in both sides of these two polders, right? So they are making a community in this portion, but depending on how much the dikes have been damaged. Now look at the dikes carefully, and you can see here are the dikes in 2012, and if I click on 2018, much damage have not been done, so it is almost intact. The banks are almost intact, not there are very huge damage. That is why I don't think maybe this community should move. If there is a possibility that the dike have been eroded to a great extent, then we can make an assumption that this community should not be here or be transferred to somewhere else. But that's how you're going to make the analysis, and I'm leaving the assumption to you to make. I'm not going to make the assumption for you. I think you will have your own assumptions later. Now to move to some more portions, there will be questions on that, how much the dike bended or did the route of the dike changed. And I have marked down an area right here. As you can see, I'm turning off this layer. You see that here is a dike. Let's add all the dikes here. Okay, here is the dike. Here is the route of a dike that we have mapped earlier. Okay, but if you look very closely, that this dike was not actually meant to be in this route. In earlier, in some years, maybe before 2012 or 2010, this dike was in this portion, right in this portion, and going to connect by here and then connecting here. But due to, as I told you, that if you find a bend of the river, that portion is very vulnerable. And as you can see, this river just bended in this portion, and that had a very heavy toll on the dikes, and that has already eroded almost most of the dikes in this portion and breached them. And that is why people had to make another dike in a inside the polders or towards the inland, so that they can protect the polders from the surges in later future. So if I look to some more areas, I have adjusted here. Here is also a thing. If you go to 2012, you can see there were no connection between these two polders, and as well there was no valid uh, 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 medium for them to transfer from one polder to another. But in 2018, that bridge has been completed, and now they can easily connect, and that's why these communities are very close to this bridge or connecting these polders. And here in this portion, this is also a bend. This is a gentle bend of a river. If I turn off this, uh, I think you guys have already understand that what I'm trying to say in this part. Do you see any change? Any major change? Right here, if you see this picture and this picture,
Yes, it is eroding, I think.
uh, Not exactly. You are right to some extent. It is eroding. This portion is eroding, right? But
Yes.
if you look carefully, there is a feature. You can see this line.
Mhm.
You can see this line. Do you think it's a dike or it's a road?
I'll have to zoom in more. Maybe it's a road. It's a road.
It's a road. Is there any possibility that it can be a dike or it was a dike, but right now its route has been changed?
I think
Because
it's
if you look
Can be a
carefully,
road,
if you
and
look
it can be a
carefully,
dike.
yeah, let me show you. Actually, it was a dike a long time ago, a very long ago. This portion was, if you see this entire route, this dike was connected from here. It goes from here, right here, and then connecting here. This dike used to go in this way and then connect to this part. But due with time, maybe due to flood, and this time was damaged, and the authority did not feel it a good idea to make rebuild it. That is why they have abandoned this dike and changed the dike route to this portion so that it can be more resilient and it can be more less vulnerable to the inland flow from river water, right? So you have to identify these features as well, because a lot of you have already did. You guys have considered it as a road, but if you look carefully, this was actually not a road. This was actually a dike, right? So while analyzing, you have to make great consideration and very careful consideration in this kind of portions to find the exact amount of dike length that was changed. Then again, some of you may say that this portion vulnerable or not, or is this portion well built or not? From my assumption, since I have been to this part, if you continue this dike and look at the upper portion, you can see if there is a you find a dike and there are a lot of vegetation in both the side of the dike, then that dike is less vulnerable, as the trees or the vegetation will give it a strong foundation. On the other hand, if you see that it's a good dike, it looks good, but it does not have a lot of vegetation and it is also very close to the river bank, then that dike is really in a vulnerable position since it's a bend. If you I turn off this layer, if I turn off this layer, and now you can see the difference, right? Here is the difference. This portion was sedimenting and this portion was just vanishing, and in 2018, as you can see, it is very clearly vanished to a lot of extent. And in 2012 there is a lot of roads, and there are also some earth constructed materials in this portion of the river banks. But in 2018, go to 2015, let's check on 2015, these constructed materials were damaged, and the flow was also towards the inland and eroding this portion of the bank. And in 2018, it is almost pretty vulnerable to the river flooding. And again, may I go to some other portion that I did not cover? Uh, well, not this part. Okay, let's go. In this section of the image, you can see that I have made some. What is this? This is actually what? Can anyone just respond? What this portion looks like? Can anyone? Okay. These are actually some trees, right? And or you can say forested land in this portion of the river bank, right? Yeah, mangrove forests in this river bank that were actually not. Can someone just turn off the microphone, please? Okay, so this is a mangrove, right? But this vegetation, was it naturally developed or people developed it all by themselves? That is the question, because as you can see, this is a bend of a river, right? and this is the outer part of the river where most of the riverbank erosion occurs or take places. So to find that out, let's turn off the 2018 and 2015 and go to 2012. Do you see any mangrove right now? Obviously not, or to some, but not that much. So within just 7 years, and this entire portion was filled with forest, or filled with vegetation, or filled with trees, and that was mainly done by the people, or the whether it was done by the local people or the authority concerned with the riverbank protection. So they made this portion filled with trees, so that when this river takes its bend with time, these trees can protect this bank from getting eroded. And why this bank is so much uh, important, just after you can see there is a huge community living right here. All right, compared to other portion, you can see, if you see this portion, there was not many protection, because not a lot of communities are living here, but compared to this portion, a lot of communities are living. So if the surge surpasses the dikes, they can greatly affect this community. That is why, as an additional protection, the forests or the trees were built in this portion to make this portion less vulnerable to the surge. Now moving on to this portion, let's check out this portion. This portion looks very close to the river bank, and it is almost all the banks are irrigated in this portion, right? And if we turn on 2018 and to check for any change, and as you can see, it was very close to the river banks, and there are some absence of dike. There is no dike actually. This dike used to be from here and going through this portion, it used to connect it right here, but right now the direction of this dike, or the route of this dike, has changed in this type. From here it is changed. So you guys have to give very good consideration in this kind of portions as well. And then move to the some more things. There is not always the things occurring that the dikes are only getting damaged. There are some good things are also happening, and we can see those from this image. Can you see clearly this portion of the image? Can you?
Yes.
So what is basically this portion represent? This is a actually shipyard. This part of the thing is a shipyard. There's a good industry right here. If any of you have been to the steel industry in this portion, and this is a very well built road over a dike, isn't it? This looks like one, right? And from its structure, you can see that it is very well built, and it is almost engineered designed. And if I turn off the layer 2018, in 2012, this neither the shipyard nor the well constructed road were present in this portion. So this was developed later, so that this community living in this portion gets some extra advantage, and they can also make some transportation from this part to this part. And that's why in 2018, during 2018, this well constructed road over a dike was built in this portion. And since this part was very close to the bend, and this already seems eroded, as you can see, yeah, this is not eroded right now, but in 15 it started to erode, and in 2018 it's almost eroded. That's why either continuing this dike into this portion, they tried to make change the route of this dike in this portion, and connecting it from here, they just continued their connection at this later part of the dike. So this is also a vulnerable portion. You guys have to make a measurement of length of this kind of areas, and then add them to your attribute table also. And moving on to the later portion, Frederick, how many minutes do I have?
We already were a bit later with the other parts, so I don't know. Actually, in the planning, we were finishing around now, but maybe you can take some minutes to explain the last things that you want to explain.
Okay, I have two more things. Then after that I will be done. So in this image, if you look, consider this is also a dike. This is also a dike, and this is also in the river banks. Like previously, this is a very meandering river, and this portion is very much vulnerable to the erosion. On the other hand, this portion will get some sedimentation. If you look very carefully, there was a dike in this portion that is not very good built at that time in 2012, and its route was very clear, right? Like here, I have been to this portion, and if I try to see it in 2015, you can see, you can see the change in the shape. The road was almost parallel to the boundary, but in 2015 they just did something. They bent this road from here to this portion, and hopefully, if I am not wrong, they also tried to make a sluice gate right here. If I go to 2018 and zoom it, no, let's go to 2015. Okay, and you can see it looks like that they tried to build a sluice gate, but for some reason they could not continue this canal. There should be a canal. So there they had a plan to dig a canal right here from this route, but this they started to dig that canal, but they did not continue later. They only built the sluice gate, and for some reason that project got stopped, and this portion never had a canal dug, and only the dike route was changed. So in this portion there is only a sluice gate, but you will miss this sluice gate, and you will think, "Oh, there is a sluice gate but there is no canal." So that is the answer to your question. This is still not completed. Maybe in near future the government will dig a canal to this portion and add it to the other canals for better drainage. And you also have to mention that how much bend this dike had, or whether it was moved towards the inland, or whether it was breached. So this is not breached. This was just change in route, and it was towards the inland. And this part of the dike is still under construction. Okay, and now for the last portion, I think I have covered almost all the sections. In, okay, I have covered this. Okay, I think I am done. And this portion is also the similar kind of things. There were some very good beach. This was used to be a beach one time. In 2012, people used to go into these places. This was an economic zone for tourists. In 2018, it is not a good beach. Some portion of the beach still remains for people, but as you can see, look carefully, maximum part of this beach has been eroded due to the storm surges from the sea towards the inland. And so these are basically the things that you are going to identify in your later assignments, and you are going to calculate the areas for all those things, and you are going to calculate the lengths for all those breached dikes, or the all those damaged dikes, and finally then use the algorithm that I showed you earlier. You are going to collect the numbers or collect the values of those areas, or those length, and then make a sum and then include those into your report. So this is for now. Lastly, I did not show you how you are going to add these images into, because if I am not wrong, I have only provided you with the link, but I did not mention it in our training videos. So for now I'm just closing all this. So to collect all the three images from different years, you guys have to do one thing. You guys have to go to the folder that was provided to you, that is the Mapathon folder. There was a text file named Python code to import satellite image. Open it, and I have written a code for you. From the source to the last portion, copy this entire code, and then go to your QGIS, and then from there go to the plugins. Click the plugins. There is an option called Python console. Click the Python console, and at the bottom you will find this box with 3 different arrow to write your code. Just paste your code here, and the code is pasted, as you can see. After you paste the code, you just run, and when you run, you can see in the XYZ tiles these 3 images will be added. So right now I'm showing you another time. I'm just removing all those things, deleting all those things from here, and also removing it from here, and again clearing the section. Just click here and paste the code, and then run, and the images are added to your XYZ tile. From here you can just close the Python console and drop your images into your QGIS window and start editing. So I think I am done here, and Frederick will continue with the conclusion part of our training. Frederick?
Yes, thanks, Asif. I think that was a great introduction and great introduction really to the folder, actually also for me to see really what's going on. A lot is happening, as Kimo said, it's very dynamic. I see some questions also in the chat, and we will try to answer those in the chat as well, because we are already running a bit late. I will share my screen for the final part of today. And then first here. We have these parts. So finally, we ask you to, as a group, because you will be mapping the folders, one by one. So each person will take one folder to map. And during the mapping, of course, you can already think about the questions that we asked you. And after this, we will send you an email, which consists of also these 2 templates. So a reporting template and a presentation template. And you can already have it to think about the questions, maybe to discuss it with your group while you are mapping. And then when you're done mapping and when you did these analyses, you calculated, for example, the length of the dikes and the areas that have changed. I'll just quickly go through. There's this reporting template where you can fill in your name and the folders that you've mapped and your group number. And there are the 4 sections of the 4 questions that we ask you to answer. So you can fill it in here, and then we collect it all before, on the last day of the Mapathon. And we also ask you to give us a bit of feedback on this Mapathon, because it's our first event even that we organize as the Bangladesh Netherlands Water Youth Forum. So we would really like to get your opinion and like to improve. And then we have the presentation template. It consists of a few slides, which just have the topic on the slide. So please do not make it larger than this, because you will only get 10 minutes to present on the final day. So next week, Thursday, and afterwards there will be 5 minutes for questions from other groups or from us. When you've handed in the report and the presentation, then we can also and also the data, of course, the maps. So we ask you to email that to the email address from which you get all of the files. We ask you to also hand in all the shape files, and then we can assess it. And there will be a jury that will assess all of this. And then finally, after the presentations, we will announce a winner.